Okay, so this is the mock hire question 2. It says here the graph below shows how the overall stopping distance for a car and the driver's thinking distance change with the speed of the car. So on the bottom we've got increasing speed, and up the side we've got the distance that the car takes to stop at those different speeds. The two lines on the graph show us the thinking distance, which is a nice straight line, and the overall stopping distance, which obviously is a curve. In the middle here we could plot the braking distance, and then the overall stopping distance would be the sum of those two. The question though asks us, use information from the graph and the equation time is distance divided by speed to calculate the thinking time for the driver at a car travelling at 15 meters per second. Okay, so what we need to do is we need to find 15 meters per second, which is here, and we need to rule a line up to the thinking distance line, and then a horizontal line where it crosses back towards the distance axis. Okay, and it seems that that's pointing at 9 meters. Okay, so the distance that the car travels is 9 meters, and the speed, as we've seen already, is 15. Okay, so we've got 9 meters divided by 15 meters per second. Okay, and if we use our calculator to ensure we get the right answer, 9 divided by 15, 0.6 seconds. Okay, so we now move on to the next part of the question. It says, use information from the graph to find the braking distance when the car travels at 20 meters per second. Okay, so the braking distance is going to be the difference between the thinking distance and the overall stopping distance. Okay, so we're looking again for 20 meters per second, so we're looking for the braking distance at 20 meters per second. So again, if we use our ruler and we discover that the thinking distance is 12, and the overall stopping distance is 42. Okay, so the stopping distance is this length here, which is 42, take away 12. Okay, so 42 meters take away 12 meters obviously equals 30 meters. Okay, so that's the braking distance. Okay, the distance that the car needs to actually stop with the brakes applied. Use the graph to give a reason why the braking distance at 10 meters per second is not half of your answer from B part 1. Okay, so as I mentioned previously, the total distance is a curve. Okay, and this is because the brakes struggle to stop the car as it gets faster and faster. Okay, so the total stopping distance is a curve would be the correct answer there. Is a curve. Okay, and as it's only for 1 mark, we don't need to go into any further detail really. Name one factor that could make the thinking distance graph steeper. Okay, and so to make this steeper, that would mean that it's taking the driver longer to think about stopping. So factors that might affect that would be tiredness, if the driver was tired, if the driver had been drinking. Okay, so if the driver is drunk, or distracted. Okay, so if the driver, for example, is using their mobile phone or any other device in the vehicle, that would make them distracted and therefore make the graph steeper. Okay,